right, good afternoon, everyone. I certainly hope everyone's having a good day today. I hope that you're staying dry. It's going to be pretty wet out there today, but that's all right. So just to kind of remind everyone of what's going on. So last class we covered a lot of stuff inside of SQL. Specifically, we covered some new things we haven't done yet. So we did different types of joins, which are very important. And we also did things like procedures, functions, all that sort of stuff. So today, I'd like to just go through and actually make some of those things inside of SQL. Before I do want to make a couple quick announcements. So just a reminder, the final homework assignment is due, I believe, November 1st. Yeah, November 1st. It's inside of Canvas. Just basically write a paragraph about, I don't remember exactly what you're writing about, so I don't want to say. I believe it's about stuff where you could actually use some of the stuff in the class, but make sure to read the prompt, of course. But just as a reminder to everyone, we'll be inside of MySQL Workbench today. So if you'll go ahead and inside of Unit 3, inside of Canvas, I posted these earlier today. I have a Chapter 10 tutorial tables. That's just going to go through and give the table definitions. Then if you'll also download the inventory, the sale, and the item CSV files, we'll go ahead and use those. So that's where we're at today. So I went ahead inside of MySQL Workbench, just created a new schema. Then, of course, just a reminder, right-clicked on it, set as default schema. So we're just going to go ahead and open up the in-class exercise for Chapter 10 tables. And right off the bat, you can see this has just 3 simple table definitions. So I won't spend a whole lot of time on this, but we're just going to go ahead and create them all at once. So let's just make sure we have everything and just go ahead and execute. And that should go ahead and let us create the tables. But we're not done yet. Of course, we want to put data inside. So we're going to refresh the schemas. We're going to expand the tables over here. And of course, we have to do this one by one, unfortunately. So we're just going to go ahead and that third icon over where it's got the table with the lightning bolt, just click on that. Go to this icon where we import. Now, since we're inside the inventory, we're going to make sure we get the inventory CSV. And if you're having any issues importing it, make sure that you open up the CSV files in Excel and save them as CSV. Sometimes they can be converted to UTF-8 transcoding. If you had to do that, it's certainly something I'd recommend doing. So we're going to use the table we just created. Of course, we know we're inside of inventory, so we're going to put the inventory data in inventory. Default should be fine. Always want to show logs. So we've got our data imported now. And that's the inventory file. So now let's do the same with item and sale. So again, we're just going to do the same exact process here. We're inside the item table, so we're going to get the item CSV right here. And again, we want to use the existing table. We want to make sure we select the item. Go to next. Again, the defaults should be fine. So we're able to import those as well. And now lastly, we do this with sale. So we want to make sure that we select the sale table. We want to put it inside the sale table. Whoops, not inventory. Sale. Show logs. Okay, so we should have all the data imported. Let's go back to the tutorial file, and let's just go ahead and talk about things a little bit. So we just went ahead and imported these different tables. So let's see what they are. So we have a table with item information. Inside of that, we have item number as the primary key. We have the item name and the item description. Now, if I'd thought about this a little bit more when I started making these this tutorial, I would have put price in here, but I forgot. And by that point, it was kind of too late to go back and change it. But we could certainly include price if we wanted to. That's definitely where we'd want to put it. Then we have inventory. So all we have inside of the inventory table is the item number and the quantity that we have of that item. And then lastly, we have sale. So you could call sale transaction, or you could call it sale. In this case, I want to keep it simple. We're not going to have a purchase. We're only going to have a sale. So in other words, we don't really, in this current model, we don't have a great way to increment our inventory if we get a new shipment in. But that's okay, because this is just a simple little example here. So these are the three main tables that we have. Any questions up to this point? Certainly feel free to stop me with any questions. But, right off the bat, though, a big part of what's inside of Chapter 10 are the various types of joins. So, early on in the semester, we would do things like select star from item, join inventory on, let's just say item dot item no equals inventory dot item no. And this is an equal join. So basically, if we select this and we run it, it's going to give us all of the stuff that's inside of the item table, and it's just going to give us a nice little table here. So basically, we just kind of did what we've done all semester. This is really nothing new up to this point. Where we start to get into some new ways to do this, though, we can do this a lot of different ways. So we could do something like select. In fact, I'm just going to copy this, because we don't have to specify the on condition. We could instead say something like using the primary key, because in this particular example, you'll remember item number is the primary key for all the tables except for the transaction table. In that case, we're using a composite key, but we're also looking at the date of the transaction. So you'll remember we can just do using, and we can type in item no. And this should give us the same stuff. Oh, I see, I forgot to highlight the line. That'll cause issues. I was wondering why. So basically, we have different ways to do stuff. Now, this is not the only ways we could go about this. We could also specify we want to do an inner join. So instead of just saying join, if we actually specified an inner join, we would only get the stuff that they both have in common. So if there's a case where there is something inside of one table that's not inside the other, particularly talking about the primary key, it won't be included inside of an inner join. So if we wanted to, we could specify inner, and then we could just run this. As you can see, that should get pretty similar results, because in this case, that's kind of, the whole thing between an inner join and an equal join could be quite similar. So these are some of the different ways we could go about doing a simple join statement. But this is not really all we want to do. So we want to also talk about different types of joins. So we had a left join, we had a right join, and we had a full join. So if we have a left join, what happens is that we look and we see we're going to get all of the primary keys from the table we have on the left. So that's basically saying whichever table we say first inside the select statement, so whatever comes immediately after from, in this case, it's going to be item. So if we just copy this previous example here, and if we make this a left join, it's going to get all of the primary keys inside of the left table, which is item. And then we're joining the inventory table, so we're only going to get those if they have a value inside. So, let's go ahead and see what we see whenever we do this, because inside of our inventory, we don't have every single item that we have inside the item table. There's some missing values there. So let's see what this looks like. So you'll see here, we don't have item number 0 inside of the inventory table, yet it's still going to be present inside of the left join because we're getting everything that's inside of the first table that we enter. So if we scroll through this, we can see the same thing is true of item 2, the milk. And then we have item 4 and 5 again. So basically, everything inside of that first table, we're going to get it. Now imagine we did the same thing, but we want to do it with a right join. So with a right join, we're going to get everything that's inside of the right table, but if it's not inside of the left table, we won't have it. So let's just go ahead and copy this and just change one little line here. Let's just change this to a right join. So now, technically speaking, the first table it's going to look at is the inventory table. So will we still have item number 4 and number 5 inside of this join statement? Well, let's see. So you can see this is only going to include the values that are inside of the right table. If they're not inside the right table, they're not going to be included. So we lose out on some information. There could be some cases where we want to have it this way. There could be some cases where we want to have it another way. We have lots of options. So that's just kind of the difference. But let's see, do we really need to have a left and right join? Could we just have a left join and do everything we could do inside of a right join? Well, let's see. So we're going to copy this left join. Whoops. And let's just change the order of inventory and item. So what do you think is going to happen if I do this? Any predictions? It should be the same as this right join up here, where we're only going to have the items that are present inside of, in this case, the inventory table. So let's just go ahead and run this. And yeah, exactly like I predicted, that's what we see. So, basically, we can kind of reverse this, and we have lots of different flexibility for how exactly we want to go about this. So if we did the same thing here, we're going to copy this and do a right join. Should be the same as the very first join that we did using the left join above. And it is. So that's really the difference between the different sorts of left and right joins. It's all about the order. So if you think about it, you have a left join. Just think about the diagram. You have two Venn diagrams, or you have one Venn diagram rather. You have the two circles. Whatever's on the left will be included inside of the left join. And then whatever they have in common will also be included. But the stuff that's unique to the right table will not be. Does that make sense to everybody? Left and the right joins can be a little confusing, but I don't think they're too bad. So there's one more type of join that we're going to talk about, and that's going to be the full join. So this is a case where, in a lot of instances of MySQL, or not MySQL, but a lot of instances of SQL, we can just specify full join, and it will get both the left and the right table and what they have in common. It will all be included. Now, MySQL doesn't actually allow us to do it that way. So to kind of get around that, what we have to do is we basically just take the two joins that we've created, the left and the right, and we just do a union between them. So basically, we can just go ahead and select both of these. And we can just plop our good friend union if we remove this first semicolon. Because if we leave the semicolon in there on that first statement, it's going to end at that first statement. So we want to have a continuous SQL statement. That's why we're going to remove that semicolon there. So if we run this, it's going to give us the same thing as doing the, in this case, the right join, but it's still cool to see. So you can see we have basically everything included, and that's going to be the full join. We're going to have every single record inside of here. So that's the kind of some of the different types of joins. Any questions about these so far? Okay, there is one more type of join we're going to cover, and that's the theta join. Now, theta join can sound intimidating, but it's not that intimidating when you really think about what it is. So all a theta join is it's applying some sort of condition to the join statement. So instead of just saying select from whatever we're selecting, we're just going to say where. So we're going to have some condition we're going to apply where we're only going to do the join if the condition is met. So for this, it's going to be pretty similar starting off. We could just do something like if we want to select, let's say we want to have the count. We get the count, and we just want the count star. We're going to keep things nice and simple. We're going to get this from the item table. And let's go ahead and talk about this a little bit. So within inside of this, a theta join allows us to do condition, but we can also do conditions within inside of the same table. So if we think back earlier in the semester, we did something called a table alias. Who remembers what a table alias is? So basically, a table alias is wherever we specify a table that we're creating on the fly based on another table. So in this case, we're just going to call it item A, join item B. And these are technically both copies of the item table. So we can certainly do this. This is within what SQL allows us to do. And now we're just going to create that on condition. So we're just going to say A.itemName is greater than B.itemName. And then we're going to specify the most important part of the theta join, which is the theta condition. So this is the where condition. So we're going to say where the A.itemName, and we could say equals, let's just pick any of these. So we have all of our item names. Someone throw me an item name. Milk. So you're talking about the, I think it's skim milk. Make sure I spell it exactly correctly. There we go, skim milk. Type in skim milk. And let's see. So we're saying where I is greater than skim milk. In other words, how many things are going to come, before skim milk? So it turns out it's going to be 0. So if we change this, though, let's say we're to copy it, and we were to say how many things are going to come after skim milk. So we just did before. Basically, what we're doing is we're comparing the order. So we're saying where will things come before and after this condition. So we run this. Let's just try beer. I think this may work a little bit better. Okay. So basically what we're doing here is we're saying that 9 things come after beer. So we have the item name beer, and that's going to say there are 9 things coming after that. I think the reason skim milk didn't work is because skim milk is the product description and not the product name. So let's just try that. Now that I think about it, I think I was looking at the wrong column a second ago. Okay, yeah, that's what's going on. Sorry about that, guys. Yeah, so basically, we can set whatever condition we want, and it's going to do the join based upon that. So what if we want to do something like see how many items that are called beer are inside of our table? How can we do that using a theta join? Well, a simple way to do it, if we weren't using a theta join, would just be to do select count star from item where item name equals beer. But what's the problem with doing that? That's not using a theta join. It's a perfectly valid way otherwise, but let's just say we wanted to. All we have to do is just set the condition to equals to. So we're seeing where the item equals beer. How many times does that occur? Well, we know it should only occur once. And when we run that, that's exactly what we get. So just to kind of show you guys what I'm talking about, if we weren't doing this inside of a theta join, we could literally just type in select. We could count star from item where item name Okay, so if we run this, we'll get the same thing, but we're just doing this inside of a conditional theta join because that allows us to not just look and see what equals it, but it allows us to compare to the other items inside of the table. So if we're only wanting to get what equals it, this is a much simpler way and probably preferable for whatever we're doing. So any questions about these joins so far? No, you can use a lot of different things. If you were looking for the average to see what's the average where the item equals beer, you could. I don't think we have a numeric value inside of item table. We have item number. We could do that if we wanted. average, let's do item no, and this is going to give us the average item number, so it should just be the item number up here. Like the item number, let's see if this works. Well, you should be able to. I'm not sure why it's not working right now. I'll think about that a little bit and come back to it, probably another class. But basically, you know, you should be able to do anything you want to inside the select statement. I think what the issue is that I've got the table alias. But this, just know that it would theoretically work. Does that make sense? All right. So there's one more thing I want to cover today. And that's something that we talked about last class. It's a very powerful thing we can do. And it's once we get the hang of it, it's not too difficult or anything. But it is a little bit different than some of the stuff we've done up to this point. So on the left side of the sidebar here, we have something called stored procedures. Now, who remembers what a SQL procedure is from last class? It's basically like a mini applet that we can run inside of whatever SQL application we're using. And we could do things like update, insert, really anything you can do inside of a standard SQL. But instead of using SQL code all the time, we can build little applets that will let us do things like if we get a new if we get a new customer, we could run this and we could input the customer's information. If we get a sale, we could run this. And not only could we put the sale inside the transaction, we could also do things like update our inventory. We could do things like update the, if we had a report, we could then update the report with things like how many sales each employee made, each salesperson, whatever the case. There's a lot of things we can do with a procedure. So let's go ahead and go to this stored procedures right here. Right-click on it. Click on Create Stored Procedure. Now, what we want to do is we want to make sure we type in a good name. We don't want to call it New Procedure. Instead, we'd want to call it something else. So let's just call it Transaction. And let's call it Transaction 1, because technically speaking, transaction is a protected word inside of MySQL and most SQL implementations. So we want to avoid calling anything that. It's like calling it an int. You don't want to do that. So whenever you create this, you'll go ahead and see that there are these open and close parentheses. Now what these are the arguments. So you're saying, what information do we need for this? If we leave it as is, there's going to be no arguments. We're not going to get any information into this argument. That's not necessarily an ideal thing. So this is called transaction. What do you think we're going to be doing inside the transaction procedure? We're selling stuff. So if we go to our sales table, we know we have a couple items there. We have the item number, we have the sale date, and the sale quantity. Now I kept things nice and simple, and I just used the sale date as a big int because I didn't feel like dealing with dates. But with this, we can actually use today's date. I think it's current underscore date. Don't quote me on that. But that's a really powerful thing we can do to where we don't have to manually input the sale date. As soon as we create the sale, it puts today's date as the sale date. So just keep that in mind. We can do this a lot of different ways. But basically, the whole idea here is that we can tell it what information we're going to be getting in. So we can literally just type in to specify that. And then let's just say we want the item number. So we get the item now. We tell it it's going to be a big int. We just want to match our previous table's definitions. Then we also want to get it in sale date. And again, that's going to be a big int. And lastly, there's one more piece of information we need. We've got the item number and we've got the sale date. We need to know how many we sold. So that's the last information we're going to get in, and that is the item quantity. And that is also a big int. Okay, so far, what this program is going to do is it's going to take that information in. So, in fact, let's go ahead and apply this and just see what this is going to look like. So you can tell it's going to handle a lot of the behind the scenes code. So up to this point, we haven't had to deal with any delimiters or anything like that. This is a much simpler way to do things. So we're just going to keep everything to default. We're going to call it the transaction 1. We're inside the right schema. I called the schema in class 102820. You might have called it yours something else, but it should handle that regardless. So when we just apply that, okay, we see that it created it. Well, where did it go? Well, if we refresh the schema window here, we expand our stored procedures, we can now see transaction 1. So if we just go ahead and hit this lightning bolt icon, it pops up and it lets us input this information. So far, we've gotten to the point where we can input the item number, we can input the sale date, and we can input the item quantity. So this isn't going to do anything because at this point, we didn't put anything inside of what's actually running. So let's go back to this, and we're going to call this now transaction 2. So inside the begin, this is where we're actually putting what the thing is going to do. So let's just start off by saying we want to insert this information into the sale table. So we'd say something like insert into, because that's where we're going to be putting it, and we're going to put it in the sale. Now, if we remember, we want to specify the values. So we just say values, and we do an open parentheses. And we're going to get those variables we just had. So we had item number, sale date, and item quantity. Okay. So this is a completed statement. So you can tell right now it's got an error. What's the error? Semicolon. So I put the semicolon in, that's going to go away. So we're calling this transaction 2. Let's see if this will work. Anyone want to take a bet with me that this will work or not? It's never a good idea to bet me. I'll just say that. So we're going to go ahead and change this from drop if exist transaction 1 because we're calling this transaction 2. So we're just going to change that 1 to a 2. Everything else looks pretty good. We've got insert into the values. Those are the values that we're inserting. So we should be in a really good place if we click apply. So we've applied. Let's go ahead and refresh. Now we have transaction 1 and transaction 2. So let's just see. Am I just full of wrong information, or will this work? Well, let's try it. So we're going to be inside of the sale table. So let's get an item number. So looking over the items, we can do 0 through 10. Someone give me a number 0 through 10.
4.
You said 3? Okay, we can certainly do 3. Now for sale date, we want to be careful on this. We don't want to pick a sale date we've already done. So I think anything after 10 should be okay. So if I just type in 33, and how many item quantity? Now this one, we can pick any number we want. So it does have to be an integer because we select the data type to big int. Also, it doesn't usually make sense to sell a partial item. There can be cases where it does. Imagine we're selling pie. Do we have to sell the whole pie at once? We could probably do pie by the slice. But most items aren't like that. So let's just say 5. So let's go ahead and execute this. And let's see if this worked. So it says we had a row affected. Let's go ahead and then go in and do, let's just say select star from, and we just did that in the sale table. And if we did this correctly, the very last row should be what we just inserted. So it's going to be sorted by item number. So we used item 3. And here we go. So we have item 3, sale date 33, and item quantity 5. That's what we just inserted. But now this is pretty cool, but is this that useful up to this point? Not that useful. So let's go ahead and make this just a little bit more useful. So anyone want to take a guess as to what we're going to do next? So we've got whatever we're selling. We've got that going into our sales table. What have we not done yet, though? We haven't changed our inventory. So instead of inserting, our inventory, if we look at it, in fact, let me go ahead and pull that up because it'll make a lot more sense. I'm just going select star from inventory, and I'm just going to run this right quick, and we're going to take a quick look at the inventory table. So we have item 1, 3, 6, 7, 8, 9, and 10. Now, looking at this, what do we notice? There's no repeated items. We have the item, and then we have how much we have of that item. That's all there is inside the inventory table. So we don't want to insert new information into it. What do we want to do instead? Well, we want to change what's already there. So inside a SQL, that's called an update. So instead of inserting, we're going to use update. Of course, we're going to update the inventory table. Now, when we do that, we have to tell it what we're going to update it with. So in this case, I don't think we've covered this yet. We're going to use a set function, and we're going to say inventory dot item quantity. And this is basically saying we're going to update inside the inventory, and this is a specific variable we're going to change is the item quantity. So we're going to take what we had before. We're just going to copy this inventory.item quantity, and we're going to paste it. And then we're going to say minus, and in this case, we're just going to type in item QTY because we're still inside the program, so this is legal for us to do. If we were outside the program, we couldn't use item quantity because, for one thing, which item quantity are we talking about? So because we've already defined it up here as item quantity, it's okay to do. But in most cases, you'd want to put the table name .item quantity. But in this particular instance, you don't. Does that make sense? If I put in sale.item quantity, that's not going to be something where there's only one value. So if we take the sale, we could have 50 sales of item number 3. We could have 50 different records for that. So it doesn't know which one to get. However, because we're inside this program and we already called it item quantity up here, we're perfectly good. So a little bit confusing, but just kind of keep in mind we're inside of one application right now. So, and then let's go ahead and call this transaction 3. Anyone see any problems? Hopefully not. I don't either. Let's just apply this. Again, just to remind everyone, when we apply this, we're going to call this transaction 3 now. So we just change it up there. Everything else looks pretty good. So let's go ahead and finish. And now, just to remind, let's refresh the schema. So we have transaction 1, which does nothing. We have transaction 2, which will allow us to update and add in records to the sale table, but it doesn't do anything with the inventory table. And then lastly, we have transaction 3. Transaction 3 is where it gets interesting. So if we just go ahead and execute transaction 3, we can now input a sale, an item number, a sale date, and an item quantity. So in this case, we want to make sure that we're keeping everything to stuff we have an inventory of. If we don't, we'll run into some issues there, and we don't want to do that. So I'm just going to use item 9 because item 9 has 6 million. So item 9, I don't remember what it is. I think it's beer. We're going to sell that. Someone give me a date to sell it on. Preferably, I would say 10 through 100. $30. We can certainly do that. And how many beers do you guys want to sell? So we've got 6 million we can sell. We don't want to go negative. We can if we sell 6 million and 1. Someone give me an integer. $12 beers, okay. So if we execute this, we just ran it pretty quick. Let's just see if that actually changed anything. So we're going to do select star from inventory. And this should be 6 million minus 12. And as we can see there, it is in fact 6 million minus 12. Now what's the issue? Well, the issue is that it took 12 off of everything. But to fix that, we would certainly want to make sure that we kept track of the item quantity, where we only did this where the item equaled the, so we'd apply a where condition here. And I believe this would be inventory dot item no equals item no. I didn't actually realize this when I was making this for the first time, so I'm not sure if this will work, but let's try it. I mean, I'm reasonably certain it will, but let's call this transaction 4, and let's just see if this fixed our issue. So again, we want to make sure that we both places. Okay. Now let's try this one more time. Let's see here. So our item number, we're still going to use the beer. Let's just say we did it on date 50. And the item quantity is going to be, let's call it 100. All right. So now let's do the same thing. We just select star from the inventory. And hopefully this will work a little bit better this time. Okay, so that's exactly all we had to do. You can see previously we had 12 taken off. This time we took 50 off, but we only did it of the beer. Or actually, I think it was 100. Yeah, last value there's 100. So that's how we would go about this, is that we would apply a where condition where we only do it to that particular value. So that's why our program iteration 4 had some problems. Any questions about anything we've covered today? All right, well, that's all I had today. Hope you all have a great day. I will see you all next class.